What's happening, guys? So I'm going to try something a little bit different. I have my three screens up instead of using my glass board behind me. I'm going to try to use just my computer screen and see how that works. All right, so what I want you guys to do is go ahead and label your notes. We're going to call it functions. 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 And the first thing that we're going to do is I want you to write this definition down about what a relation and what a function is. So I'm just going to read this verbatim. It says a relation pairs inputs with outputs. So you guys have known in the past that your x values are your inputs and your y values are your outputs. When a relation is given as an ordered pair, just like we just talked about, the x coordinates are your inputs and the y coordinates are your outputs. Now, a relation, so every x and y relationship is a relation. But more specifically, a relation that pairs each input with exactly one output is a function. So that last sentence right there is key. Try to remember that last sentence moving forward. So I'm going to give you a couple examples to make this sound to make it make a little bit more sense. And what I want you to do is go ahead and pause this, make sure you get that down, and I'm going to move on to the next piece here. No, we don't want to save that. All right, so here's a few examples. So what I want you to do is go ahead and pause the video right now. Let's copy down A, B, C, and D. So just pause it, get it down. And then when you come back, we'll go over it. All right, so hopefully you paused, hopefully you wrote that down. Now we're going to get into each one of these. So remember what we talked about with a relation. We know it pairs exactly one. So let me restate that. A relation pairs each input. So each input has to have exactly one output. So each input has to have exactly one output. So I'm looking at this. Each input, okay, -2 has 2, that's fine. -1 has 2, 0 has 2, 1 has 2. So there's no repeating x values here. So we're okay because -2 has its own output. -1 has just exactly one output. 0 has one output. 1 has 0 as an output, so just one output. 2 has one output. So we're good with this one. So this one would be your would be a function, right? Because if you think about it, we know that the fact that for every input, there's exactly one output. So now let's look at the next one, letter B. 40, 87, 64, 43, and 52. What do you think? Do you guys think that's a function or just a relation? Well, this would just be in a relation because the fact that 4 has two outputs. 4 has an output of 0, and 4 also has an output of 3. So we know that letter B is not a function. Okay. Now we can use a table as well to show inputs and outputs. So we can see if this relation here is a particular function or not. So let's see if this relation is a function. Let's go ahead. 2 has an output of 3. 1 has an output of 4. 0 has an output of 5. 0 has an output of 6. Okay, ding, ding, ding. We stop right there because 0 has two outputs. It has an output of 5 and 6. So we know that it is a relation and not more specifically a function. All right, looking at D now, input output. So this is a mapping diagram. You might see it like this. Now let's see, -1 has one output, good. 3 has one output, good. 11 has one output. So D would be a function. All right, so pause this if you need to, if you want to go back to it and think about what that one was about, go for it, go right ahead. All right, let's take a look at example 2 now. We're going to go ahead and take a look at example 2. And before we even get into this, what you guys need to know and what I want you guys to write down is the vertical line test. All right, some of you guys may have seen that before. You may have talked about the vertical line test before, but I'm going to go ahead and put up a diagram real quick for you about the vertical line test. And here is a core concept for you that we need to know. So we want to make sure that we remember this. All right, so the vertical line test. It's basically a graph represents a function when no vertical line passes through more than one point on the graph. So all we have to do is look at this and make sure that we can determine when we have it, when we have a graph. Hold on, I'm just looking for my mouse. Where'd my mouse go? Now that I found my mouse, sorry about that, guys. You can see on the example on the left there that that is a function because it only hits at one location. Now, when it's not a function, it's going to hit the graph at 2 locations or more. It doesn't have to just be 2. So we know that the one on the left passes the vertical line test. The one on the right does not. Okay, so make sure that you can see that. All you really have to do is draw in a line or use your pencil. I sometimes use my pencil and just put it on the screen and go, all right, how many times does it hit my pen? How many times does it hit my pen? Does it hit it once? Good, it's a function. It hits it twice, it is not a function. So let's take a look at so pause and jot that down, vertical line test, have that example in your notes so you can look back at it, and you should be good to go for that. So let's look at this example. All right, determine whether each graph represents a function, and looking at letter A, we want to see if I make a vertical line test. So if I go ahead and put a vertical line straight through here, unfortunately I can't draw on this document because I'm not in Kami, but hopefully you guys can see that if I drew an imaginary line through this right here, that would hit those 2 points. So we know that 2 actually has an input of 2, and 2 also has an input of 5. Same thing with 5 has an input of 1, and it also has 5 has an output of 1, and it also has an output of 5. So really, this fails the vertical line test twice. So let's see what they say. You can draw a vertical line through 2, 2, and 2, 5. Yep, we talked about that. So the graph does not represent a function. So you should be okay with that one. Looking at B, I want to see if I can draw straight lines all throughout this thing, and I could. I would only hit at one location. So this guy would pass the vertical line test because no vertical line can be drawn. So the graph represents a function. All right, so the next thing that we're going to look at here is finding the domain and range of a function. So what you need to know, and what most of you guys probably do, like, Mr. Deschler, we know that the domain of a function is the set of all possible input values. So it's all your x values. When I say domain, in your head, you should be thinking x values. X values are my input. The range of a function is the set of all possible output values. So when you hear range, you should be thinking y. You should be thinking what comes up. Now, if you notice this little machine here, this is a function machine. Whatever you put into it, you get something out of it. So think of that in terms of a machine, input, output. The function would be your equation. So input and output. All right, so the next thing that we're going to look at is we're going to find the domain and range of a function represented by a graph. So if they give us a graph, so go ahead and jot this down. Pause this if you need to, and jot A and B down. All right, now that you've jotted those 2 down, let's look at A. We want to know the domain of A and the range of A. So all we have to do is really write out the ordered pairs, right? We know the ordered pairs of the x values here, what's in blue, those are our inputs. Those are our domains. And then the outputs would be -2, 0, 2, and 4. So if you notice, these dots are not connected, so it's not continuous. So when we do write our answer, or the domain and the range, make sure you just write it the way that it's written. So the domain is -3, -1, 1, and 3, and then the range is just -2, 0, 2, and 4. Okay, so pause this if you need to, take a look at it. Remember, this is a video, so you don't have to rush through this. Just take your time with it. All right, so the next one basically has a bunch of different values in it. So let's look at this. We want to identify the x and y values represented by the graph. So it's really every x value that's between -2 and 3. All right, so -2 and 3, every single x value that's between that. So what you should notice is that is the domain, right? So if you look on this graph, it's everything from this point to this point. So you notice how they put a little dashed line in there for you? So that's going to be a domain, and the range is going to be the vertical movement up and down. So from whatever value this is, so 1 all the way up to 2. So when we write that out, this book uses inequality notation, which you guys are used to. But what I want you guys to do, and we'll go over this in class, but what I want you to do is convert that into interval notation. So how would that be written in interval notation? If you figure that out, if you figured out the domain and range, pause this, figure out how you would write that in interval notation. All right, so let's take a look at this next example that we're going to get into. In class, we'll go over that last example about interval notation, but I want to make sure that you guys can try to struggle with it on your own, or hopefully you guys are good with the interval notation. Now, the next piece here is basically identifying independent and dependent variable. So by definition here, it says the variable that represents the input value of a function is the independent variable. So think about it. It stands alone. It's the value that I substitute in. It's my input. It stands alone because the output is the dependent. The output depends on what you put into the machine, right? So think about it as I always think of this in terms of a vending machine. I hit A2 and I'm expecting to get a bag of Skittles out, right? So what I put into the machine, it's going to spit something out. So that might help you wrap your head around independent variable and a dependent variable. So the variable that represents the output value of a function is the dependent variable because it depends on the value of the independent variable. When an equation represents a function, the dependent variable is defined in terms of the independent variable. Very wordy, guys, but try to put that in your own words, right? The statement y is a function of x means that y varies depending on the value of x. Okay, so y is not always, but the majority of the time in this course, or the f of x value is always dependent on the x value. So when you see that statement, when I say the statement y is a function of x, y is a function of x because x is the input, x is telling us what y will be. So that means that y varies depending on the x. The y is dependent on the x. Right? So hopefully that makes sense. And we can talk about that in class. So if you have questions, go ahead and write your questions down on your notes. All right, the next piece here, let's go ahead. Last example. We're going to look at this. The function y is equal to negative 3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. So we don't know how many gulps that we take, so it's unknown. We want to identify the input independent variables. So think about this. What is dependent on the other? So I know that the amount of fluid that is going to be in this container depends on how many gulps I take. So if that's the case, my independent variable is basically your gulps, and the amount of y of juice remaining depends on the number of x of gulps. So that's how they put it. I would probably have stated it the other way, but that's totally fine too. So we know that the y, the juice remaining depends on the number of gulps. So we know that the y is the dependent variable and the x is the independent variable. All right, so hopefully you can wrap your head around that, but please ask in class if you're confused on that. And the last one, B, the domain is 0, 1, 2, 3, and 4. What is the range? Well, think about this. I take 0 gulps. How much is left in the container? I take 1 gulp. How much is left in the container? I take 2 gulps. I take 3. I take 4. So what you want to do is you want to make a table, input-output table, and think about it. These are all my inputs right here, right? I have 0, 1, 2, 3, and 4. Up top here is my function. What am I putting into my function? I'm putting in the amount of gulps into that function. So the function machine. What gets spit out? A 12. Makes total sense, right? If I don't take any gulps, I know that this container is 12 ounces because it has 12 ounces of fluid in it. That's the beginning amount, or my y-intercept if you think about it that way. If I take 1 gulp, just 1 gulp, then I have 9 ounces left. If I take 2 gulps, I have 6 ounces left. If I take 3 gulps, I have 3 ounces left. If I take 4 gulps, it's all gone. Because think about that, right? We know that these should be negatives too. So hopefully when you see this on my screen, it doesn't look like a negative, but hopefully you can see it as a negative. So if you think about each gulp I take, 3, 6, 9, 12. If I take 12 gulps, that's what's in the container. So now it is gone. So the range of this particular function or problem would be 12, 9, 6, 3, and 0. And you're using a table, an input-output table. So if I ever say use an input-output table or use a table, that's what I'm referring to. So this is just a quick introduction. Hopefully you guys have seen this before or talked about this before in your previous courses, but if not, now you have an understanding of what a function is, independent variables, dependent variables, and things of that nature. So we're going to do some practice in class, but please ask some questions. And remember, we're going to go back to the interval notation. So if I forget, be like, hey, Mr. Deschler, talk about that interval notation on that previous problem.